Now, image position, when we are dealing with convex mirrors, there are 6 important cases for the finding the image position, and we'll deal with these 6 cases in one and the next and the subsequent classes in 6 different classes. So these are very important cases. And why is that? Because questions, objective questions, can directly be solved if you remember these 6 cases. It is not necessary to solve the numerical using the mirror equation all the time. If you remember these 6 cases, sometimes the questions are directly asked. So definitely subscribe to the channel, and that way you will be ensured that before your exam you will cover all the 6 cases one by one. So today we are dealing with the first case, okay, and this is the first case. And the first case is that this is the center of curvature, and we have the image, the object placed beyond the center of curvature. Okay, so object is not at infinity, but it is beyond the center of curvature. When the object is at infinity, we know that the image is formed at the focus. Now what happens when the object is I have brought it closer and closer. I have brought it from infinity and I am bringing it closer. I have brought it to a location close to the mirror, closer to the mirror. It's not at infinity anymore, but it is not, it is still beyond the center of curvature. So where would the image be formed in this case? Okay, so that is the first case. Okay, that is the exercise. We are bringing the object from infinity closer and closer, closer and closer, closer and closer, and we'll study different cases as they happen. So definitely subscribe to the channel, because very important this exercise. So now we have already looked at the equation. See, one way to find the location of the image is to do some ray tracing. Okay, and that is of course simple, that we can do. We know what the principal rays are and we can do that. So first is we bring a ray parallel to the principal axis. It will pass through the focus. This is the first ray. Second ray, we will just take it through the center of curvature. This is the second ray. Because it's going through the center of curvature, it will be reflected back 90 degrees, and where these two intersect, this will be the top of the image. Okay, so that is one way we can retrace it. Okay, but let's try to understand it intuitively. Where would it fall? Okay, so this is the equation. From this equation, can we find out where our image would actually fall? Okay, so it will definitely be on this side of the focus, because when the object is at infinity, the image is falling on focus. So it will definitely be on this side of the focus, but where? Let's try to find it out. So the first thing that we understand is that my u, okay, so this is something that I am doing with u is greater than 2f. It is even beyond the center of curvature. So which means that 1 by u is less than 1 by 2f. Now this quantity here is 1 by u. Let me replace it with 1 by 2f. Since I am replacing it with bigger quantity, 1 by 2f is bigger, therefore this becomes bigger. Very easy, this becomes greater, right? Because this 1 by 2f is bigger than 1 by u. So if I replace 1 by u with 1 by 2f, obviously this equality will not hold, and this side will become larger, this side will become larger, and that is what I have expressed here. Very simple, nothing complicated. So this means that 1 by v is greater than 1 by f minus 1 by 2f, which means that this is 1 by v is greater than, see, 1 by f minus 1 by half. 1 by f I can take common, 1 minus 1 by 2 is 1 by 2f, okay, which means that v is less than 2f. Now this is what we have come to understand also, that my image distance will be less than 2f. What does it mean? It means that my image would be formed from this equation. What I am saying, this is 2f, but my image would be formed less than 2f, which means my image would lie in this region. Okay, but we know that when the object is at infinity, it is at focus. So when I'm bringing it closer and closer and closer, and it is reached, not reached C yet, it's not reached center of curvature, the image has to lie between this and this region, between C and F. Okay, because the image, it has to be beyond the focus, but by this equation we can say that the image has to be less than 2f. It has to be after the C, after the radius of curvature, and therefore the image has to lie between C and F. Okay, so that is what we have found out, and that is what this case is all about. Now as I bring the image closer and closer and closer and closer, and I take it to C, as I bring my object close to C, the image is formed at focus. Okay, so at infinity, the image is, when the object is at infinity, the image is formed at focus. As I take the object closer and closer and closer, the image moves in this direction, and when the object reaches C, then the image is actually formed at C itself. Okay, so the image, as I am bringing the object from infinity to C, the image is moving from focus to C, and when the object is at C, both the image and the object, they reach C. So that is what is happening here. Okay, and this is the diagram, this is the image which we can see in real practical. For those of you who are doing the physics practical, you would have already observed it in your physics lab. Okay, so in the next class we will take up another important case, and there are 6 cases which will enable you to solve the problems directly in your exam.